Hello and welcome to the video. Let's try to solve this example. We are required to find the force response of the system, which is described by the following difference equation. Now, the input is given as x of n is equal to 2 to the power n u of n. So you can see here that this is a right-sided sequence. Now, it's very important for us to realize that force response is the response just due to the input only. So, we need to have all the initial conditions as 0. That means the initial conditions will not be playing any role in finding the output over here. So, we assume the initial conditions as 0. Let's try to first of all take the unilateral z transform here. So, the unilateral z transform of y of n is y of z minus 5 by 6, this is a constant value now, times the unilateral z transform of y of n minus 1 is y of minus 1 plus z raised to minus 1 into y of z. Next, minus 1 by 6, and then the unilateral z transform of y of n minus 2 is y of minus 2 plus y of minus 1 into z to the power minus 1 plus z raised to minus 2 into y of z. So this is for the third term, and this is equal to x of z. Now we assume the initial conditions as 0. So that is why y of minus 1 is 0, and hence this term will vanish. And even y of minus 2 will vanish along with y of minus 1 as shown over here. So let's try to group together similar terms. We have y of z here and here and here. So if I take y of z common outside, then we will have its coefficients as 1 minus, now look at the coefficient of y of z here. So this is going to be 5 by 6 z to the power minus 1, and then the coefficient of this term is going to be minus 1 by 6 into z to the power minus 2. So these are the coefficients over here. Now the remaining terms all are zeros, so this should be equal to x of z. Now please note here that x of n is 2 raised to n u of n. Obviously the value of x of z will be given by 1 divided by 1 minus 2 times z inverse. Now rearranging this equation, we have y of z is equal to 1 divided by 1 minus 2 z inverse as it is into this entire term, that is 1 minus 5 by 6 z raised to minus 1 minus 1 by 6 z raised to minus 2. Now we can very easily factorize this term and try to express it. So we are going to change this fraction as 1 divided by 1 minus 2 z inverse into, we have 1 minus 1 by 3 z to the power minus 1, and along with that we have 1 minus 1 by 2 z raised to minus 1. Now these two are the factors of this particular term. Now I can always solve this using the partial fraction expansion method. So I'm going to write this as a divided by 1 minus 2 z inverse plus b divided by 1 minus 1 by 3 z inverse plus c divided by 1 minus 1 by 2 z inverse. So I need to calculate the values of residues a, b and c. Let's get started. First and the foremost term is a. So its denominator is 1 minus 2 z inverse. So let's see how we can actually calculate its value. So we have a is equal to, the expression is y of z, so I'm just going to refer to it, y of z into 1 minus 2z to the power minus 1. Now this should be obviously evaluated at z equal to 2. So if I look at the previous slide, uh, the denominator of a, which is 1 minus 2z inverse, if it is taken to the other side, then I'll have the only other two terms left, which are 1 divided by, the terms are 1 minus 1 by 3 z raised to minus 1 into 1 minus 1 by 2 z raised to minus 1. Now this must be evaluated at z is equal to 2. So if I substitute the values over here, which is 1 divided by 1 minus 1 by 3, z inverse is going to be 1 by 2. This is the first term. And then we have 1 minus 1 by 2. Now z inverse is going to be 2 because z is equal to 2. So if I evaluate this expression, it's going to be equal to 8 by 5. So that's the value of a. So I'm going to note it down now. A is equal to 8 by 5. So this is the first residue we have. Now similarly, let's go back and calculate the value of b. Now the denominator of b is 1 minus 1 by 3 into z to the power minus 1. So let's get started. B will be now written as y of z into 1 minus 1 by 3 z raised to minus 1. This should be evaluated at the value of z is equal to 1 by 3. So now this will get me an answer of 1 divided by the other two terms in the denominator of y of z over here. So 1 divided by 1 minus 1 by 2 z to the power minus 1 into 1 minus 2, that is this term, 1 minus 2 into z to the power minus 1. This must be evaluated at z equal to 1 by 3. So if I substitute the values over here and then calculate it, this is going to be equal to 2 by 5. So we note the value of b as 2 by 5. This is one more intermediate answer. Let's try to calculate the value of c. Now, if you look at the residue c, its denominator is 1 minus half z inverse. So I should calculate the value of c as y of z into 1 minus 1 by 2 z inverse. Now this should be evaluated, if you look at it, this should be evaluated at the value of z is equal to half. So this is going to get me 1 divided by the other two factors, 1 minus 1 by 3 z to the power minus 1. If you refer back, among these three factors we'll have the remaining two factors, and then this is going to be multiplied by 1 minus 2 z raised to minus 1. Now this should be evaluated at z is equal to half. So if you calculate it, it's going to be equal to minus 1. So we say that c is equal to minus 1. So let's try to write the expression y of z. Therefore we write y of z or y of z is equal to, the first term is a. So we have uh, yes, 8 by 5. So 8 divided by 5 divided by 1 minus 2 z inverse. Now this is what we have. If I go back, then we have the value of b as 2 by 5. Then it will be written as plus 2 by 5 divided by 1 minus 1 by 2 z to the power minus 1. Okay, let me just, sorry, 1 minus 1 by 3 rather. 1 minus 1 by 3 z to the power minus 1 plus the last value is minus 1. That divided by 1 minus 1 by 2 z to the power minus 1. Okay. So now it's time to take the inverse z transform. So taking inverse z transform, we have yf of n. Now this corresponds to the force response. So yf of n is given by, the constant is 8 by 5 And we know the inverse z transform of 1 divided by 1 minus 2 z inverse. Now that's equal to 2 to the power n u of n plus 2 by 5, the constant as it is. Now we have the term as 1 minus 1 by 3. So its inverse z transform is 1 by 3 raised to n u of n. Then we have minus because of this residue over here. The term is 1 minus 1 by 2 z inverse. So we have its inverse z transform as half raised to n followed by u of n. So this is the required forced response of the system. So this is how we calculate it. Thank you for watching the video.